Hey, this is Ken Rosever, and I wanted to talk to you about inequalities, set builder notation, interval notation. This section 2.5 is found in the intermediate algebra book, but it's also critical that we review it in college algebra. So I'm going to post this to both PAL sites, my intermediate algebra and my college algebra. This uh, worksheet here reviews or introduces the concepts of set builder and interval notation. So when we are dealing with equations in one variable, depending on the degree of the equation, we generally get a solution set consisting of a set number of solutions, no solutions, one solutions, two solutions, which we write in braces. However, in certain cases, we do sometimes what do I want to say? We do sometimes get infinitely many solutions. Let me show you what I mean by that. Like sometimes you solve an equation like, 2x minus 5, let's make it 2/3 x minus 5 equals 7. How would we solve this? We'd add 5 to both sides because 5 is equal to 5. These would cancel. We would have 12. We'd multiply by the reciprocal. We'd get x equals 12 times 3/2, which is 6, which is 18. So x equals 18. Since there's only one solution, we would write 18 as the solution set. Now sometimes we would do this and we might, after a bunch of simplification, let's say we had 3x minus 2 equals 5x minus 2 times 3 plus x, and we solve that, we would distribute this. We get the negative 6. We distribute the negative 2 again. We get negative 2x. 5x minus 2x is 3x. 3x minus 6 equals 3x minus 2. And at this point, if we continued, we would lose the variables, and we would be left with a contradiction. And so in this case, we would have the empty set being the solution, right? And sometimes you can have the same thing happen, but maybe you get something like 2x plus 5 equals 2x plus 5, which is an identity. And then you have infinitely many solutions, which sometimes we express in this way, where x is a real number, or we put it in interval notation. Now, if neither of these things are familiar to you, that's okay, because that's what this video is about. Let me show you the place, though, where interval notation is used most frequently, and that is in the solving of inequalities. In the past, when you would solve inequalities, you would represent the solutions on a number line. So let's say you had the same equation as above, only it was an inequality that said greater than or equal to. Well, everything would be exactly the same, solving it down to the last step until we got to x is bigger than or equal to 18. And the reason everything would match all the way down is because at no point do we multiply or divide by a negative. And that is the only time where the inequality would flip directions. So this 18 is going to be the same. And this direction is going to be unchanged. So before, we would represent this solution as x is everything bigger than 18. So it's to the right of 18. And that's how we would do it. But now we have something called interval notation. 18 is here. Way out this way is infinity. Way back this direction is negative infinity. So this complete set of solutions is impossible to write in a list. You can't say it's 18, 19, 20. That's wrong. especially, oh, this should be filled in. So 18 is part of it, but there's a lot more numbers than just 18, 19, and 20 in here. There's 18.1, there's 18 and a half, there's rational numbers, irrational numbers. So how do we write it? How do we get and capture all these numbers after 18? Well, we go, it's the set of values bigger than or equal to 18. So it's anything from 18 to infinity. And this is the shorthand way of writing that. So that's what I want to review in this sheet with you guys, this notation, interval notation. You'll notice that on the infinity I put a parenthesis. You'll notice over here I put parentheses as well. When I say that this is an identity and the set of solutions is any real number, I mean basically the whole number line is shaded in. So from negative infinity to infinity. But you notice that neither negative infinity or positive infinity, neither one of them has a parenthesis. Well, what's the difference between parentheses and brackets? The difference is this. Brackets are reserved for values that are part of the solution. Parentheses are given to values or symbols that are not. 18 is part of this solution. Infinity and negative infinity are not. Really, infinity is not a number. It's more of a direction. It's not something you can actually count and say, oh, how many people are there? Infinity. It's not a defined number. It's more of a direction. It's an idea, and you can't really include it as part of a set. So that is why you will never, ever put a bracket on an infinity. Okay, so make sure you make a note of that. Infinities always get parentheses, and numbers get brackets when there is an equal sign which includes them. Okay, let me do another example here, and I will do it of what's called a half-open interval. Sometimes we solve three-part inequalities. I'll do a very basic one. And we get kind of a interesting result because what we do is whatever we do to the middle, we do to the outsides. So since all the x's are in the middle, we don't have to break this up into two different inequalities and solve them with an and in the middle. We can just go, oh, because 3 is less than or equal to x minus 5, which is less than 8. That means adding 5, adding 5, adding 5, that x minus 5 is between, oh, 5 is gone, that x is between 8 and 13 with the possibility of being equal to 8 because it's bigger than or equal to 8 and less than 13. So a number that is bigger than or equal to 8, here's 8, here's 13, and simultaneously less than 13 would be somewhere in here. Lots of numbers meet these two conditions, like the number 10. But this condition includes that we can be equal to. So this would be the old-fashioned graphical representation of this interval. This interval can also be expressed in interval notation because this is closed in, because this has an equal sign, because 8 is part of the solution set. 8 is included, 8 gets a bracket. 13, which is not included, gets a parenthesis. You'll notice that 13 does not satisfy the equation or the inequality given. 3 is less than or equal to 8, which is less than 8. This part of it's true, but this part is not. So 8 does not satisfy, or 13 does not satisfy this inequality. However, you try an 8 here as x or anything in between and it'll work just fine. Let me put the 8 in there. I'm substituting x with 8. So 8 is taking the place of x, so let's see what I get. 3 is less than or equal to 3, which is less than 8. Well, 3 is certainly less than 8. Is 3 less than or equal to 3? Yes, it is. So any value in that interval satisfies the equation, or the inequality. These kinds of things come up. Oftentimes, both of these inequalities match. They're either both closed circles or closed intervals, like -4 to 4. If the absolute value of x is less than or equal to 4, then x is between -4 and 4. You'll see that in a later unit, in Unit B of college algebra. So that's called a closed interval. And that means for this to be true, x can be anything between -4 and 4 inclusive. If I had absolute value of x is less than 3, then my answer would be -3 to 3, but not inclusive, right? If the absolute value of x is between -3 and 3. All right, let me go to the worksheet now, and I'll go through all these various possibilities.